I wanted to give you a bit more feedback on Lab 9 since recursion is a bit more of a mind stretcher than our previous lab problems. So let's take a look at the 5 assignments we had for Lab 9. Number 1, write a recursive function that returns a string ha in times, in being an argument. For example, laugh 5 should return the string ha 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 ha. So 5 ha's. So let's see if we can break this down into a smaller instance of itself. So if we start with the suggestion that they give, 5 ha's, I guess I gave, not they. Let's personalize this. So that's 5 ha's. Is it possible to break down this string into smaller instances of itself? Yeah, it is. Because 5 ha's is the same as writing 1 ha and concatenating the rest of the string, the other 4 ha's. And 4 ha's is the same as taking out that first ha and concatenating it with the last 3. Writing 3 ha's would be a ha string concatenated with a 2 ha string, and so on. 2 ha's would be 1 ha plus 1 ha. Well, 1 ha string would be ha plus nothing, or in code, that would be an empty string. And if we wanted to go one step further, 0 ha's would be nothing, which in coding is an empty string. So we can see that we can break this down into smaller instances of itself. We can take out the first ha and concatenate it with the rest of the string. And we can keep track of how many times we want to do this with this number here. So we have use for this number that we're going to pass in as an argument to our function here. And we have what we need to take out, what operation we need to do, and then what our recursive call is going to look like. Recursive call will be the same function, laugh, with in minus 1. So 5 minus 1 is 4. So the recursive call, the first recursive call will be laugh 4. And this is how it looks in code. So we see that a recursive call takes out a ha, or creates a ha actually, uses a concatenation, the string concatenation, so all of this has to be a string, and then calls laugh with in minus 1. When we get down to 0, because we need it to be a string, and we need the string to concatenate with this ha, which will concatenate with this, and this one, and this one, and this one, all the way up. So we have to start with a string and return that. So we need to pay attention to what's being returned all the way back up through the stack, or all the way back down through the stack, depending on how you draw it. Then we are going to return a string. And this particular one chose to do n equals 0 as the base case. And since 0 ha's would be an empty string, it's returning an empty string. But as usual, or as often happens, we can do a base case of either 0 or 1. In this case, we could have done a base case of n equals 1, which in that case, we would have ignored the empty strings and just returned a string of 1 ha. It would have worked the same. Let's take a look at the next one. Number 2. Write a recursive function that takes a string and returns everything minus the last letter. For example, cut last, ABCDE should return ABCD. So again, can we cut this into a problem that is smaller instances of itself? Let's take the example string. Can we break that down into smaller instances of itself? Sure. When we think about this, one way to do this would be to take off each item and then return everything but the final item. So the first time we would cut off the first item and then return the rest of the string. And then cut off the first item of that string and return the rest. Then take off the first item and return the rest of the string. And then take off the first item. And here we have the final item of the string. So we get down to our base case, which is when we have that final item left. And instead of returning E in this case, what we actually want to do is return an empty string, because we don't want to return this. So we're going to gradually take off each item. When we get to the last item, that's going to be our base case. We want to return a string, but we don't want to return that final item. So in this case, we can't go down to 0. We have to stop at 1. That's the point when we want to return an empty string, which will be concatenated to D, and then they'll concatenate to that C, and then B, and then A, all the way back up. And this is what the code looks like. So you can see that we've cut off the first item, and then called that same recursive function with everything but the first item. And of course, how do we keep track of when we've got down to that one item? Well, very simply, we use the length of the string. So it doesn't matter what's in the string. When we've got down to that string with only one item, we don't want to return that final item. Instead, we're going to return an empty string, which will be returned here and concatenate to the first item over the previous list, which in the first case, in this particular example, would be D, and so on and so forth, back up the stack or down the stack. Let's look at the next one. Number 3, write a recursive function that cuts out the first occurrence of some letter in a string. For example, cut out A, B, C, D, E, F, and what we want to cut out is the first instance of D. So that's the second argument in our function. So it would return A, B, C, E, F. So these are gradually getting more difficult, but we can still break this down into a smaller instance of itself. It's fairly similar to the previous one. If we think about it, we have our string A, B, C, D, E, F. We can get rid of, or we can take out each item from the string one by one, just like we did before. A, if we take out A, then we have B, C, D, F. We can return that. If we take out from that string, we're going to have B, and then C, D, E, F. And then we'll take out C and D, E, F. And then we get to D. And that's going to be take out the first item and have E, F left. This is actually where our base case is going to be, because this is where we want to stop. Once we take out that D, it doesn't matter what is in the rest of the string, we can just return it. So that's actually our base case. Once we've got to that first instance of the element we want to remove, we can just return the rest of it. And so at this point, what we want to do is return the rest of the string minus that item. So it would be like an empty string, or just ignore it, cut it out, and just return this and concatenate this to that. Let's see how that looks in code. So here's our recursive function. As I showed, we can take out the first item and then concatenate. Again, we're taking this from how we broke down our problem into smaller pieces. This is the first item, this is the operator we want to use, and then this is what our recursive call is going to include. So we have the first item, we have the operator, we have a recursive call with the rest of our list minus the first item, and then of course we need to pass down the element that we're looking at. And that's going to lead us to our base case. So in this case, we know we've reached our base case when we see that the first item is that element. So the first item in this list is D. And that's when we reach our base case. And so we want to return everything but that element, in this case EF. So we simply return the rest of that string minus that first element when we get down to that part. So we're going to return EF to this point, which is going to be concatenated to C, and then CEF will be concatenated to B, and BEF will be concatenated to A, and we will have AB, C, EF as required. One more. Actually, two more. These are gradually getting more difficult. Write a recursive function that reverses a list. For example, reverse 1, 2, 3, 4, 5 should return 5, 4, 3, 2, 1. All right, let's walk through this one. I'm not going to write the list, I'm just going to write the numbers. So we have 1, 2, 3, 4, 5. What we want to return 5, 4, 3, 2, 1. So can we break this down into a problem that is smaller instances of itself? Well, this one takes a little bit more creative thinking, but if we think about how do we start reversing a list or a string? Well, the first thing you could do is cut out the first item, as we did in the previous two problems, and put it at the end of the list. Concatenate it there at the end of the list. And if we do that, then we can break that list that's left, take out the first item and concatenate that. Put that first item at the end. That's how we would start making that 2, 3, 4, 5. That's how we would start making that work backwards. We take the first one and put it at the end, and so on down the line. Put the first item at the end. When we get down to 1, here's 2. Put that first item. When we get down to 1, well, reversing a list of 1 is simply putting that item into the list again. We can actually go on down to 0. So again, this is a case where the base case could be when we get down to a list of 1 item, or we could get down to a list of no items. So we could take out 1 more item and have an empty list. And of course, the reverse of the empty list is the empty list. If we use that as a base case, then that would return and concatenate. Let me get my spotlight here so it's easy to see. It would return the empty list and concatenate what was left in the previous call, which is 5. So an empty list concatenated with a list with just 5 would be a list of just 5. And then that list of 5 would concatenate with 4. So we'd have 5, 4. That would concatenate with 3, 2, 1, on down the list, which should give us 5, 4, 3, 2, 1. Now notice this one's a little bit backwards in how we did it. In this case, the thing we took off is at the end of the list. Our operator is before it, and the recursive call comes first. So this is what it looks like in code. Our recursive call is down here in the else statement. It comes first, then the operator, then the first item. So one by one, we're taking the first item of the list and putting it at the end. And this one uses the empty list. So when the empty list, when L, the list that we have, is empty, then we're going to return that empty list. So we're starting here, and then start concatenating at the end of the list each of the first elements that we peeled off in the previous calls. So that one took a little bit more creativity, and also the realization that a recursive call and the thing that we're concatenating or what other operation we need to do can go on either side of the recursive call. Final one, number 5. Let's get rid of this. Write a recursive function called remainder, which takes 2 positive non-zero numbers, n and m, and returns the remainder when n is divided by m. For example, remainder 10(3) should return 1. All right, let's first of all write this out and see what's happening. So we're going to get n, the first of the arguments, 10, and divide it by 3. And what we want to do is return the remainder. So if we can write that as we would in code, what we're actually trying to get is 10 divided by 3 modulo 1, something like that. Actually, that, of course, would not be correct. Let's rewrite that. Okay, so what we're trying to do is 10 divided by 3 in code. Let me write that in a different line. Would be 10 modulo 3. And that would get us 1. Okay. Now, if you remember our discussion about modulo way back when, we illustrated it by showing a different way of thinking about division. So you can think about it in this symbolic representation, or you can think about it as subtraction. So 10 divided by 3 is actually 10 minus 3 minus 3 minus 3, which leaves us 1 if we don't want to go into decimals or negative numbers. So if we think about this division problem in this way, then we can see that division is something that we can break down into smaller instances of itself, and we have a recursive solution, or the possibility to get a recursive solution. So let's try that. So how will we do that? Well, it's simply dividing. Our recursive call is going to be a division. So the first time it's going to go 10 minus 3. And here we need to check. So 10 minus 3 is 7. And here we need to check whether or not we want to continue. So this is the first instance we've had where we actually have to check. The condition is going to be not where our base case is, but whether or not we want to continue with a recursive call. And what we want to look at, since we don't want to go into negative numbers, is whether 7 is greater than 3. Because if 7 is greater than 3, then we continue our subtraction and not go into negative numbers. And it is, so 7 minus 3 is going to get us 4. Let's check again. 4 greater than 3? Indeed, yes. So let's do another subtraction. Here's our recursive call. 4 minus 3 is 1. Is 1 greater than 3? No. So then that's going to stop our recursive calls. And we're just, for the base case, all we have to do is just return this number. So there's no concatenation that needs to go on as before. We're not working with a list or a string. We're just returning one number. So once we see that the condition of our remainder from subtraction is no longer greater than 3, then we just return that number. In our recursive case, what we're going to do is think of our division as subtraction. So we're going to call our division again, and we're going to see if that's greater than 7. If not, we're going to call it again. Remember that we're thinking of division, we're thinking about division as subtraction. That's the way we're thinking about it. But we can just think of it as subtraction as well, as division with the remainder. So we're going to call, our recursive call is actually going to be, we can actually subtract this, right? And what we're getting there is actually our remainder. So actually, we could just take all of that out as we did above and think of what we're doing as 10 modulo 3. And then the result from that would be 7. So even though we have subtraction there and it seems like a different thing than division, whether you think of it as division or modulo or subtraction, it is recursive. We have to do that for each one. So we can use this to be a recursive call. But the easiest for me to think about it is in terms of subtraction. So that's what I used in the code here. So note this is backwards from what we've seen before. Our recursive call is under the if statement. So this can happen sometimes. Again, you have to think creatively, think about what you have, write it out, practice it, work through the stack, see what works. But it is possible, although probably not as common for the recursive to have a condition. But in here, we're trying to make sure that the number we're dividing by or subtracting is still greater than or equal to the one we're dividing by or subtracting from. And we're going to make our recursive call be subtraction in this case. So n minus m, and then the remainder that we want to check. So the first time it's going to be 10 minus 3. We're going to make sure that 3 is in there to check it. The next time it'll be 7 minus 3, and 4 minus 3. And at that point, n is now 1. So the next call, we come through. N is 1. M is still 3. We check the condition. 1 is not greater than or equal to 3. So we go down to our base case, and in this case, we simply return the number.